All right, then I will. Stand back, everyone. To infinity and beyond!
So what's up, guys? Here we go. This video we're going to talk about end behavior of polynomial functions when we actually graph them. And the idea behind it is this. Very generic, very basic. When you graph any type of a polynomial function, I'll use one that we know very, very well. It's near and dear to our heart. It's the old parabola. When you graph this thing, whatever it looked like, remember it looked like a U-shape for sure. However, any particular polynomial function that's a continuous function, that's what we're talking about here, these arrows, remember, represent and mean that this graph would continue to keep going. Well, this end behavior idea is saying, okay, there are two, if you will, ends of these graphs. Here would be kind of one of them. Now, that's not the end of it. End, the word end is being used very loosely here because these things never end. They would keep on going forever. However, what you're really kind of looking for, and this video is going to talk about, is the tendency that the end of this particular graph is going to have. For example, this guy here is going to keep going forever and ever and ever in that direction right there. It's not going to all of a sudden then bounce back down and come back down. Nope, it's going to keep going there. Likewise, the left side of this particular function is going to be graphed and continue to keep going up as well. Now, I know that you're sitting there saying, wait, Motter, can't we have a parabola that goes this way? Sure. Well, this particular graph then would have a tendency that it would keep going down this way. It would keep going down negatively on the y-axis, and this one here would keep going down negatively on the y-axis. But yes, we have other functions too. If you remember the cubic function, where there was a cubed as the degree, a third degree polynomial, it might look like this, where it come down, bounce, and then go back this way. Well, guess what? This one has a tendency that on the right side, it's going to end going down this way. This one's going to end going up that way. So we're looking in this particular video on the end behavior and how we actually write it and denote it and figure out which way these actual things go. So on to your graphic organizer. So in the top left graphic organizer, what you're going to see is the word linear. So the linear example that's above it, you need to pull that down and rewrite it. Remember, this is a linear function, polynomial function, because the degree is a 1. Now, what I want you to see down here with the terminology, it says, as the x values approach this symbol right there, and that stands for negative infinity. And you're going to be like, what in the world? By the way, that's why the whole video started with to infinity and beyond. So if we were going to infinity, so as x value approaches negative infinity, and what does that mean? I put an example there for you. It means that the x values continually get negative and more negative and more negative and more negative and more negative. So you keep getting bigger, 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 if you will, on the negative axis. So you keep actually getting smaller, 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 quarter, 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 quarter. You know what? In fact, do this. Turn your graphic organizer over, and I'll give you an example of what this really means. So what I would do is on the back of your graphic organizer, maybe like half of the page in the back of there, draw an x and y axis. You know, this is your x-axis right here, and this is your y-axis right here, but we actually also know this is f of x. Remember, that's the same thing. F of x and y represent the same thing. It's just the outputs of the function. It's the range values. That's the outputs of the inputs of x of the function. Okay? So regardless, here's what you need to write. If I pull myself as a little stick figure, that's right, I kind of cropped my head and put on a stick figure. If this is me, and I go back to this example here, that it says the x values approach negative infinity, meaning the x values continually get negative. That means this. As I'm standing here at the origin, and if I keep walking on the x-axis, bounce on the x-axis, bing, ba-ding, 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 I'm getting negative, blah, blah, blah. If I keep going in that direction, where I'm at -4, -7, -50, -300, -1000. If I keep going that way, eventually, well, there's no eventually, I would just keep walking forever and ever and ever. And the way that they represent in mathematics, not the end, because there isn't really an end, numbers that are really, 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 really small is with that negative infinity symbol. So what I would recommend you doing on your graphic, or on the paper here, is over here to the left, write this really, really big. Write negative infinity. Likewise, if I'm standing here on the origin and I start walking way over here to the right, well, yes, you got it. That's actually positive infinity. So over here, write this nice and big. This is positive infinity. Beautiful. So that's what this thing is meaning whenever it says, hey, what's the deal? What's the end behavior of this linear function, linear graph of this linear function, whenever x approaches negative infinity? So here's the scoop. If I graph this, which actually, you know what? Hold on one second. Let me pull this over right here, and I'll graph it on my graphic or my thing. So it's 4x minus 3. So when I graph this, you'll see, bing. So there it is, just a straight line. I know it's kind of hard to see, but it is just a straight line. But the point is, as x approaches negative 8, so as I would be walking on this x-axis right here, going to the left, keep on going that way. The question is, then what are the values of f of x actually doing? So which way are my values of f? So my y values. So as I walk left, what's the actual end behavior of the graph going? So is it going down or is it going up? Well, guess what? Yup. Back to your graphic organizer, if you flip that thing over, here's what I would write. You got it. I would write up here, this direction up here, if I'm walking or I'm kind of going up the ladder, this is positive infinity in the f of x direction, if you will, or the y direction, the y-axis. And then down here, yup, this is negative infinity. So the graph of this one looks like this. It's going straight line like over this way. Ooh, right over my head. Whoa. Forgive me, picture that being straight. So as I'm walking here in the negative direction, bleep, 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 it's asking as I'm going left, what's happening to my y values? Well, you can see my y values are going down. And I'm going to show you this on this particular calculator. Hold on one second. So what I want you to notice over here, I'm going to hit this trace button. Now you can see it's blinking right here. So it's on x equals 0 and y equals negative 3, which makes sense because the actual y-intercept is negative 3. So what I want you to notice is this. I'm going to keep hitting the left button. So as I go left, what I want you to notice is these x values. Check them out. Look how they keep getting more negative, more negative, more negative, more negative, more negative. Keep looking. So they're going negative 8, negative 9, negative 10, negative 12, negative 13, negative 15. You can see the graph is actually shifting over to the right because I'm walking more to the left. But what I want you to notice now is this. As my x values are going more negative, they're going more negative, more negative. They're approaching negative infinity. What I want you to now focus on is what's happening to the y values. Keep watching, keep watching, keep watching, keep watching, keep watching, keep watching, keep watching. So these x values keep getting smaller and smaller and smaller. Notice what's happening to the y values. They keep going more negative. So to finish this particular chart here, what you would say is as my x values approach negative infinity, with this thing going like that, as my x values approach negative infinity, the y values are approaching negative infinity as well. Oh yeah. So likewise though, what happens if my x values are approaching positive infinity, which means if I walk this direction? Well, I wonder what would happen there. Let me pull this up again. Let me hit this little button here so it works. Should work. Let me go back to the graph. Zoom, hold on. Back to the beginning. Okay, so now I'm going to trace it again, and what I want you to notice is this. I'm going to hit the right button. Now check this out. Look at the x values as I'm going higher and higher and higher and higher. So I'm walking more on the x-axis to the right. Now I'm over here at 10. Now I'm over here at 11. Now I'm at 12, 13, 14, 15. So my x values are getting bigger and bigger and bigger. And notice what's happening with my y values. Oh, they're going in the positive direction. They're getting bigger. So I'm at 100. Now I'm at 110. Now I'm at 120. So you can see as I keep walking over here on the right, the y values keep getting bigger. What does that mean? That means as my x values approach positive infinity over here, that looks like an 8, sorry. Wow. My y values keep getting bigger and bigger and bigger. So this would be positive infinity. Bam. So now you get the idea, at least behind this. As the x values approach negative infinity, that means I'm walking left. What's happening to the y values? Beautiful. So that's one scenario, at least the idea about how it works. Now let me scoot down here and show you this cubic function. Well, let me first of all graph it up here for you. Let me go to zoom 6. I'm going to change this completely. Let me graph this guy for you. I'll make it negative 2x to the third power plus 5x minus 1. Now I'm going to graph this. Now you know it's a cubic, so you should know what it should look like. But check this out. Whoops. Oh, I know what happened. Sorry, hold on. Let me get back to this. Hit that. Hit this. That needs to be this guy. Excuse me. 1 second. There we go. So check. Oh, look. It's a nice little Z shape, and it should be. But the question is, as my x values approach negative infinity, so as I start here at the origin, and I trace to the left, as I trace to the left, and the x values here keep getting more negative, check out what's happening. Whoa. Check out what's happening to the y values. So as my x's are getting smaller and smaller and smaller, look what's happening to my y values. They are getting absolutely enormous. I'm at 4,000, 5,000, 6,000, 7, 8. Now I feel like an auctioneer. So as my x values, keep getting more and more negative, negative infinity, then my f of x values keep getting bigger and bigger and bigger. So that would be, in this example, positive infinity. So what you should do is draw a quick sketch of this. It looks like this, like that. There you go. So now you have it. So as my x values approach negative infinity, my y values are approaching positive infinity. On the flip side, oh yeah, on the flip side, let me change this. I'll zoom 6 it. Back to the beginning. So now as my x values approach positive infinity, that means I'm going this direction. What's happening to my y values? Well, yes, you can see it's actually going down. So they go in the negative infinity direction, just like that. Beautiful. So there is those two. Now, why did I do those two? Because if you notice, it was a cubic function and it was a linear function. Those degrees were odd-powered degrees. So there's a little summary that we're going to have here with odd-powered degrees. Okay? So quite simply, guys, the summary is this. If you have an odd-powered degree polynomial, whether it's a 1, a 3, a 5, a 17, it doesn't matter. If the degree is odd, you know they're going to look like this. They're going to go this way, or they're going to go this way. Like I'm cheering. Ha, 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 and 1, and 2, and work. They're going to go this way, or they're going to go this way. Which means one's going to start up here in the top corner like such, and it's going to come down here, and maybe it's a cubic where it bounces like that. Either way, you know it's going to look in that direction right there. Or maybe it's going to look like this. If it's a 5th degree, crazy I know, it could start down here, come up, bounce around 1, 2, 3, 4, 5, like that, hence 5, because it's 5 different directions that it's going. But it could look something like that. Either way, if it's, if it's linear, then it's just a straight line. That's supposed to be straight. Either way, that's how it looks. Or remember, linear can go like this. Cubic could go like this. Or not cubic, sorry. Yeah, cubic can go like that. A 7th degree would go like this. 1, 2, 3, 4, 5, 6, 7. Like that. That's how all odd ones go. Beautiful. Let's now talk about the even ones. So on to the even power one. So you see this is a quadratic. It has a 2 degree. A 2nd degree polynomial is called quadratic, as you know. So as the x values approach negative infinity, that means again I'm going left. So I'm bouncing to the left. The question is, which way are the y values going? The f of x values. Well, if I graph this thing, you all should know this. I did it again. Hold on a second. My goodness. Enter. Do this. And make this a negative, like that. Okay. So you all know, oh, right, it's a parabola. Oh, right, the leading coefficient's negative. That's why it's going down for sure. So as I trace this again and I make my x values, notice my x values are getting smaller and smaller and smaller. So as I'm walking left on the x-axis, the y values, notice, whoa, they're getting smaller and smaller and smaller. So yes, you got the idea. This is my parabola for this one. Looks like that. So as my x values in this particular case are going left, my y values, my f of x values are going down to the negative infinity. So as x goes to negative infinity, the f of x approaches negative infinity. And likewise, if I'm going to the positive infinity over here to the right, my y values, my f of x values are still going down. So it goes to the negative infinity power. Or not power, just negative infinity. So there's your quadratic. So if I come down now to the quartic functions, where I have a 4th degree polynomial, and I graph this thing over here to the right, boom, there you go. It's a W shape. Oh, look at that. It's actually going up, which it should be because the leading coefficient is positive. A little hint there. So this W, I'd recommend doing this, Running it so it comes down like this, something like that, whatever. Actually, that's not all that accurate. Hold on. Should probably, yeah, you should probably move that up. Let me back that up. Let me back that up. I'll put it up here. There we go. So, bottom line is this. As you see, as I trace these things and I go to the left, as my x values get bigger and bigger and bigger, or sorry, negative, more negative, more negative, as I approach negative infinity, look what's happening to my y values. Whoa, they're getting really huge. So it's approaching positive infinity. So that's the end behavior of that one. As the x values go this way, on this side of the graph, it's actually going up. On the right side of the graph, oh look, it's positive infinity as well. So what's your summary with even-powered polynomial functions? It'd be basically this. If you have an even-powered, like a quadratic, where it's going to be a parabola, like this right here, you can see, oh, look at that. That's a pretty good parabola, Motter. They're all going to be like this. Remember, if parabolas are either going to be U-shapes, or they're going to be smiley faces, or they're going to be frowny faces. Smiley faces or frowny faces. That's it. But wait, if I have a fourth degree polynomial, like these, then I know it's going to be the same thing. It's either going to be a frowny face with a little blip in it, like a W, or it's going to be, oh no, it's going to be a frowny face with a little blip in it, like that. Like it looks like an M. Ooh, what if I had a eighth degree? You got it. If it was, it could go this way. They're either going to go both the same way, up, or both the same way down. Odd power ones go in opposite directions. Odd power ones go in opposite. Even go the same, same. Odd, odd. Even, even, odd, odd. Even, even, odd, odd. You just got the summary right there. But an eighth degree one, just to finish this video up, would go like this. If it was a positive leading coefficient, it would go down 1, 2, 3, 4, 5, 6, 7, and then bounce up and go 8. So notice even the end behavior would be up here, and it would be up here. It still is going to be this way. Even, even, odd, odd. We'll see you in class. Later.